Welcome to Chapter 3, Date Time, Time Delta, and Period data types. We've seen these data types before, but like we've done in the previous chapters in this part, we're going to go much deeper into all three of them so you have a really firm understanding of them. All right, so let's go ahead and cover their definitions. Again, a date time is a single moment in time. It contains both a date and a time. So the date has a year, month, and date component. The time is hour, minute, second, and part of a second. So here's an example right here. June 8th, 1989 at 10:45 a.m. and 33.456 seconds. A time delta is an amount of time. It has units of days, hours, minutes, seconds, and parts of a second. It's not attached to any date. So like here's an example, 5 hours, 34 minutes, this many seconds. A period is a span of time. So the key thing about a period is that there's always a start and end of a period. There's different units that depend on the length of the time period. So for example, June 8th, 1989, this could be a time period where the start time is right at midnight and the end time is right before midnight of the next day. Here's another example of a time period. All right, so the real world usage of these data types will be covered in the time series part. So there's a large section of the book called time series that will cover actual real world examples. We're just going to cover the data types themselves in this chapter. All right, let's get started over here, creating some datetime64 data types. So pandas and numpy each have a datetime64 data type, and they are actually a little bit different. Pandas datetime64 always has nanosecond precision. The numpy's datetime64, you can give it a specific precision. So you can have precision just to the minute, hour, day, so forth. So it does operate differently. Pandas always gives you precision down to the nanosecond. And in our first example, we are going to convert a series of, this is not something common that you can do, but it's something that is possible. You can convert an integer series to a date time series with the as type method. So the way this works is you pass in datetime64 and then you put brackets over here, and you have to pass in some unit of time over here. So how are you going to treat these integers? Are they going to be seconds? Are they going to be minutes? Are they going to be hours or whatever? And let's just treat them as, say, actually we'll just go with years in the beginning. And what pandas does, so this is interesting, it treats them from years after the epoch. So you have to know what the epoch is. So the Unix epoch is considered like time period or time zero, date time zero, and that is January 1st, 1970, like this. So this is 0 years after the epoch. So this is exactly the epoch itself. This is 4 years after. This is 30 years after. If we change this to say seconds, you'll see that now this is 0 seconds after the epoch. This is 4 seconds. This is 30 seconds after the epoch. So sort of interesting behavior on how this works with as type. Again, not something very common, but that's just how it operates. Now you might be wondering, why isn't it showing nanosecond precision? Well, it actually is. If you do dot values over here, it'll go back into a numpy array and it'll show all the precision all the way down to the nanosecond, which is 9 decimal places. So even if you have a year over here, it'll still show that precise precision in numpy. But in pandas, it nicely just doesn't show all those excess zeros for you, even though they do exist under the hood. All right, something that's a little bit more common on creating a datetime with the series constructor is to actually use a string for the date times. And one of the patterns you can use is this over here. So you format your string like this, and then you just make the date time. You actually have to use nanosecond precision over here as the D type. So these are just the precision, millisecond, nanosecond, whatever. But in the series constructor, you always have to use nanosecond precision. And in fact, it doesn't matter. Pandas will always use nanosecond precision, even if you try to use years. So I know it's different than with the as type. I don't know if this is a bug or whatnot, but that's just how pandas works. And as a general statement in pandas, it's good to just test out the code first with something and then figure out what it's doing, because it's not always the most consistent library. All right, so let's go ahead and create a series of date times. And even though I didn't provide all of the components over here, it's still it always has them underneath. Pandas always goes to nanosecond precision for any datetime64 data type. By the way, there's no datetime32 or datetime16. It's always 64 bits date times, and they always have nanosecond precision. So it is consistent with that. All right. Now, how can you add missing values? Well, you can actually use the string NAT with the lowercase a, or you can use the NAT object. You can even use the pd.na object as well. And pandas uses the NAT object for for not a time. So this is its missing value representation in a series. All right, so that is some information on how to construct series to be datetime 64 data types.